can.
Oh, yeah, oh yeah, Linda, yeah, you're unmuted. Good. So we have again continuing on our roll here. I'm just so delighted with these talks. Our next speaker is Linda Shore, and she's going to be telling us about promoting public science literacy through astronomy. Linda is presently the director of the Astronomical Society of the Pacific, and has a long and distinguished career in teacher education, and also has been a PI, principal invest. Actually, she's chief executive officer. Sorry, not the director.
Fine.
My bad. She's been a PI of a number of National Science Foundation awards. That's our in the United States, our main science funding organization. Science, it used to be the main science education funding organization. And she was also, she was the senior staff scientist and director of the Exploratorium Teacher Institute for about 11 years. Exploratorium, for those of you who don't know, is one of the most marvelous science centers in the United States, and just it's just an amazing, amazing site. So I'm sure Linda contributed to its well-being. But now let's, Linda, why don't you go ahead and share the screen, and I'll mute out here.
Sure. I will. Thank you very much, Carl, and thank you everybody on the committee for inviting me. I'm really honored to talk before all of you, and hello to the folks on Facebook and people watching on the archive. I'm going to share my screen so we can start right in on the slide here. And Carl, your job will be to tell me if you see it. Here we go. You see the slide?
It looks good.
It looks good. Excellent. Okay, then I'll go and get started. So as Carl introduced me, I'm the CEO of the Astronomical Society of the Pacific. And what I thought I would talk to you about today is what it means to promote public science literacy through the lens of astronomy. And I'm going to talk a little bit about how the ASP has done it over our 132-year history. I won't do the whole history. Just as a way for us to think a little bit more deeply about what the definition of science literacy really is and what it should be in today's world and in the world to come. We're going to start though with a poll. I'm going to do something interactive here. And oops. I understand that we have a poll waiting for you. Here it is, Linda's poll. So I know that there's lots of different definitions of public literacy and everything is important. But just for my curiosity, more than anything else, if you could pick the most important goal of public astronomy engagement, what would it be? If you could only do one thing, would it be increase appreciation for and interest in astronomy? Would it be to improve astronomy knowledge, changing astronomy misconceptions? Would it be to increase appreciation and understanding of the tools of astronomy research, like how to use a telescope, looking through a telescope? This is how we collect data and analyze it. Would it be to promote the stewardship of planet Earth, like dark sky preservation that we just heard about? Or would it be to develop critical thinking skills and evidence-based reasoning in general? So if you could just do one, or if you could pick one, what would it be? So go ahead and take the poll, and at some point, the poll will close. And for those of you who are watching on Facebook and you can't do this, you might want to just think about it. What would you choose? All right. Hoping all of you have picked something. Give you another minute. Got a minute left. And again, all of these are important. I'm just curious to know what you think is the single most important if you had to pick one. All right. I don't know. Can we tell if everybody's done the poll? All right. Can we see the results? I'm curious. Here we go. There we go. Okay, this is really interesting. So, and there's no right answer to this, by the way. You all got an A. Thank you very much. Most of you think it's to increase appreciation and interest in astronomy. And you can see this yourself. I'm not going to I'm going to take a screenshot though, because I always like to know what my people think. All right, thank you. We can take that poll away. Take a screenshot if you want. So the reason for doing that is just to get us thinking about all the different ways that public literacy is defined. So I want to tell you a little bit about how the Astronomical Society of the Pacific came to be. I don't know how many of you already know about us, but we were founded in 1889 at about the same time that the great scientific societies began to form. Most of you, or many of you, are in the International Astronomical Union. You'll recognize it, formed in 1919, National Geographic, 1888, the American Geophysical Union, 1819, the Royal Astronomical Society in 1820, the Royal Astronomical Society of Paris in 1887, I believe. They all formed around the same time. Why is that? Well, if you think about being a scientist in that period, this was, there was no internet, there was no way to share, no conferences really. It was very difficult to travel. You couldn't simply go somewhere and go to a conference. So societies formed as a way to disseminate information about research to the community of scientists. Many of these societies, in fact, virtually all of them, eventually opened their doors to the public and decided that public literacy meant bringing the public into meetings so that they would learn about geology, they would learn about geography, they would learn about astronomy. Well, the ASP is no different. So let me give you a little history. The ASP actually formed because of an eclipse. There was a total eclipse of the sun, which passed just north of San Francisco in what's now the wine country, actually near where I live. And so a group of amateur photographers decided they wanted to team up with some astronomers and go north, which was not easy. There were no bridges and you had to figure out how to get across the water, no cars, you had to carry all these telescopes by carriage, to go north of San Francisco and to photograph the eclipse. Photography was a brand new technology. This group of amateur photographers wanted to see if they could use a telescope and take images of this eclipse for the first time, and that's what they did. And here is one of the images from that outing. The astronomers and photographers got together 1 month later. The eclipse was New Year's Day, 1889. And on February 7th, 1889, they all met at the Pacific Coast Amateur Photographic Society, which is somewhere on this street. And they shared photographs and stories, and they decided that they enjoyed this meeting so much that they wanted to form a society right there on the spot. And the society they formed that night was the Astronomical Society of the Pacific, which was half amateur photographers and half people who were interested in telescopes. Well, shortly thereafter, the first director of Lick Observatory was the founder and first president of the Astronomical Society of the Pacific. And in the very first journal article, we published a journal, the Proceedings of the Astronomical Society of the Pacific. Some of you may have published there. We've published it since 1889. The first issue talks about the society. And I want to read this to you. Finally, we have among us those who have joined us as learners, who are here to listen, to observe, to read, and to study. They in turn should find in our meetings what they seek for and require. Their reading and their study can be guided, and it is among them that we may look for our workers after the next few years. This is an important sentence. Every class of talent and opportunity ought to find its profit either in our meetings or in our publications. The decision made by the society was that anyone was welcome. Anyone who wanted to learn astronomy, to teach it to other people, to be inspired was welcome, with the hope that they would then generate the next generation of astronomers. That was their definition of science literacy at that time. Well, that mission to be inclusive and to promote the teaching and learning of astronomy remains with us today. So our core value is that we believe that astronomy is a democratic science. It's available to everyone because the same sky that a researcher might use in Europe is available to a child in Detroit, is available to everyone. So astronomy is a field of endeavor, available regardless of your age, gender, ethnicity, economic status, or abilities. Our vision is a world in which all people understand astronomy and, almost more important, are able to share their passion and knowledge with others, and to do that in a way that increases the fold. And our mission, and this is where we'll talk about science literacy and what it might mean, is to promote scientific literacy, public science literacy, by engaging scientists, educators, astronomy enthusiasts, and the public in the awe and wonder of astronomy, to use astronomy as a tool to increase literacy in the public. Well, what is public science literacy? It is all the things on that poll that I showed. It's content knowledge. You might recognize this as Kepler's law. It's skills and capacity to do research, know how to use a telescope, understand scientific practices, and the ability to think scientifically, to use critical thinking skills. It's certainly all of those things. But why does it matter? Why does it matter to have a scientifically literate society? I'm talking to the converted here. I think you all have an answer, but I want to remind you where we are today. If you've never read Carl Sagan's The Demon-Haunted World, Science is a Candle in the Dark, and it was written in 1995, but it's particularly, I think it's prescient, and I think it has a lot of wisdom for today. And I'm going to read you this sentence, or this section. I have a foreboding of an America in my children's or grandchildren's time, when awesome technological powers are in the hands of a very few, and no one representing the public interest can even grasp the issues. When the people have lost the ability to set their own agendas or knowledgeably question those in authority. When, clutching our crystals and nervously consulting our horoscopes, our critical faculties decline. Unable to distinguish between what feels good and what's true, we slide almost without noticing back into superstition and darkness. So this passage means a lot to a lot of people. It certainly means a lot to me and the staff at the ASP. This notion that our job as astronomy communicators is to prevent society from slipping into darkness. And that's kind of poetic, actually. So we know we live in a society, in a world where there are, when I first discovered there were flat earthers, people who believed the flat earth societies and people who believed in flat earth, I thought it was sort of a joke that these were not really serious people, that nobody could possibly be promoting this. But there are, of course, groups that believe that scientists have duped us, that really the earth is flat, and scientists really don't know what they're talking about, and are conspiring against society to try to convince everyone the world is round. You may have in your countries, we certainly in the US have a large anti-vaccination movement. And these are people who, in their best, have been convinced that vaccines are dangerous, and that they're more dangerous than the diseases that they're meant to prevent. For example, in the case of the measles vaccine, there are people who believe that it causes autism. And this was a notion promoted by various people who turned out to be discredited. There's no science at all that shows that the measles vaccine causes autism. Yet that's still a belief that's so strong that parents do not vaccinate their children against measles. And as a result, we have measles outbreaks. We know we have a COVID pandemic across the world, 23 million cases in the world today, in total. But in the US and in other countries as well, there are many people who have been convinced that the COVID death numbers are fraudulent, that the disease is not as serious, that masks, for example, won't prevent disease, and that in fact it might make things worse because somehow you're trapping virus in the fibers. None of that's true, but they're strong beliefs. And these aren't new. This is not a modern problem. This slide on the left shows an advertisement for an anti-mask meeting that occurred during the influenza pandemic of 1918. And in San Francisco, there was the Anti-Mask League, and they also believed that masks might actually be dangerous, that wearing them might make you sicker, and that there was no evidence to show that wearing a mask would help you. It's not just medicine. Many of us know that comets are associated with bad omens and evil things. And this is an image of Halleys Comet, a more modern image. But when the comet appeared in 1910, I think, I hope I get that date right, there was the belief that this comet was going to be dangerous because the Earth was going to pass through the comet's tail. In fact, here's the source, one of the sources of that belief. Yerkes Observatory discovered cyanogen in the spectrum of Halley's Comet. And cyanogen is actually a highly toxic thing. You don't want to breathe it in. It will kill you. The astronomer Camille Flammarion, who is the founder of the Royal Astronomical Society of Paris, was asked by the media, by the newspapers, what he thought of this. And he in fact did say that in his opinion, this would be actually a very dangerous thing and is something that we should be concerned about. And here it is. But the second part of his sentence, which I looked up, was never quoted. The second part of his sentence was, but it's probably not going to be a great deal of gas, so it probably won't impact a lot of people. And if any kind of sickness or illness breaks out, it'll be the sickness, the euphoria and joy of seeing a comet in the sky. That part was never quoted. So it caused enormous panic. And even though other astronomers came to the fore and it tried to explain to the public that there was very little gas in the tail anyway, and cyanogen made up a very, very tiny amount of it, and the chances that you'd breathe it in were so small, it didn't matter. It led to comet panic, and many people came up with cures, right, to try to pills that you would take to prevent you from being poisoned by the cyanogen. Well, the comet came and went, and no one died. So how did the newspapers report this? Only scientists were hurt by the comet. So scientists were judged as getting it wrong. They said we'd be hurt and we weren't. Of course, scientists never said that. And scientists thought we'd go through the tail. Well, it didn't quite go through a lot of the tail. So newspapers were into reporting that scientists were wrong. Well, science is often wrong, right? That's the nature of science, is to be wrong and then learn from those mistakes. But that's not part of what the public understands about science, right? So I show you this really cute little cartoon because it showed up on Facebook a few weeks ago, and I've actually been staring at it for a long time. And it was actually, I have to say, it sparked this talk that, you'll get data and you'll see patterns in data and it becomes information. And information, when you connect the dots, when you connect pieces of information, you gain knowledge. And sometimes epiphanies occur in the knowledge. Things emerge you didn't expect, and that becomes insight. And when those connected, they become wisdom. But when does it become a conspiracy theory? When does it become something that the public believes so strongly that they don't believe what scientists have to say? And this, I have to say, I stared at this for a long time. And this is another cartoon I found that I kind of like, and I think it encapsulates what's going on. Here's a scientist at a blackboard with all of these equations, and someone walks in and says, nah, some guy on Twitter just said you're wrong, so therefore you're wrong. So the problem for we astronomers is, how do we get people to understand what an expert is? What is an expert opinion? When is a theory valid? When is an idea valid? And can we use astronomy to teach people these things? This comes from medicine, actually. Those of us in the social sciences, we can't go all the way up this pyramid, but many sciences can. And in medicine, sort of the lowest level of information is expert opinion. There's nothing wrong with expert opinion. If an astronomer says that going through the comet tail is not going to cause you any problems because the gas is not dense enough, you don't have to worry, that has more weight than if your neighbor, who may not know a lot of astronomy, says, don't breathe that stuff in, you'll die, right? And you can see the pyramid goes all the way up, case control studies to randomized trials to meta-analyses to systemic reviews, trying to make the point, and you may have heard this phrase before, that extraordinary claims require extraordinary evidence. Not only do they require extraordinary evidence, but they require extraordinary peer review, extraordinary analyses by many, many different scientists looking at the data. These are all things the public sort of needs to understand and experience. They need to experience it to understand it. And so now let's talk a little bit about what the ASP has been doing. And by the way, if I start to run over, I'm hoping somebody pipes up and says you're running over. So these are legacy programs, some of the programs we've done. So we're 132 years old, but we really didn't get into the business of astronomy education and public literacy really seriously until 1994, which is a long time ago, with a project called Project Astro. And maybe some of you hearing this talk have been part of it. So Project Astro was a project that partnered professional astronomers and amateur astronomers with classrooms and classroom teachers. And the point there was to let children see real astronomers, real scientists, to understand how they think, to let them experience it. We published 2 huge volumes of classroom activities so that astronomy could be brought to the classroom for the first time. Now remember, in the early 90s, hands-on astronomy was an unusual thing to try. So bringing in manipulatives was a big deal. This eventually branched out to become Family Astro, where we engaged families in some of these. We developed kits. But the whole idea behind Project Astro, which goes on to this day, there are sites across the world actually that still do this work, is to bring astronomers to classrooms in a meaningful way, to show kids real scientists. More recently, the ASP is involved with, manages actually the NASA Night Sky Network. Some of you on this call might be involved in that. And here what we do is we specifically develop amateur astronomers who work within their clubs. We work with amateur clubs across the country, almost 500 across the US, and help them work with communities more effectively. Again, they are wonderful representatives of science. They can show people the tools of science and explain the tools of science. And lately, what we've done is we've partnered with the Girl Scouts through the SETI project, and we've been helping astronomers be better at engaging with girls. Most amateur astronomers in clubs are older, my age. They're white and they're male. But the Girl Scouts represents a diversity of girls. And astronomers have to learn how to communicate with girls in a way that encourages them to think, that doesn't accidentally discourage a girl by making assumptions about her. It's been really successful. And we continue to offer these workshops on how to make an astronomy experience more equitable for little girls. More recently still, we've decided it's important to start as young as we possibly can. So we've developed a program with NSF support to develop activities and books for very early learners, ages 3 to 5. And these were designed for museums, but we've now developed some materials for schools as well to work with early elementary kids. And the idea here is to use astronomy to develop critical thinking skills. And at this age, what's a critical thinking skill? It might be the ability not just to observe something, but to notice. At this age, if you can get very young children to notice that the moon changes shape or appears to change shape over the course of the evenings, that is a big deal. If you can get them to notice their shadows changing, that's a big deal. But kids are capable of creating theories and explanations and making meaning. Meaning making is an important part of science, and that's what we're doing with these books and these activities. Well, we now are in the COVID era, and we believe that COVID eventually will go away, but this virtual learning is going to grow during this time and is going to evolve and hopefully become more equitably distributed to children, so that all children have equal access to virtual learning. What's the ASP doing? If you go to our webpage, and I'll tell you later how to do that, you will notice we now have an Astronomy at Home page. And this is tiny writing, I apologize, but you can go and look at it yourself. Our Astronomy at Home page is designed to help families working with children at home, right? To have them work together to look at the night sky, to do some activities that we've posted, but we also have regularly scheduled storybook time. And here's an example. If you're interested, one's coming up on Monday, September 14th at 11 o'clock in the morning, Pacific time, 2 p.m. Eastern time. And I'm sorry, I don't have it in Universal time. We'll be reading Zoo in the Sky, a book of animal constellations. And what happens at these meetings is children will take the webinar along with their families. We've now noticed that their grandparents living in homes that are away from them and they're isolated are joining these readings as well. Each reading is focused on astronomy, but has an activity. So this is the activity that goes with this particular book. Create your own constellation. What image do you see in the stars this time of year? Here's an example of one in the sky. Can you draw your own animal? And so what kids are going to do is bring their pictures to the session and share what they created. Again, we want them to make meaning out of data, to learn to think like a scientist, to develop their critical thinking skills as young as they possibly can, so that as they grow up, they have more success in developing scientific thinking skills and hopefully become more scientifically literate adults. Here's an example, another example of the session going on live. And here we have one of our books called Moon Bear Shadow, written by Frank Ash. And we have an activity that goes with it where we shine a light on a little bear, and the little bear gets a shadow. You see the shadow here. And there's a bunch of challenges like, can you make the bear shadow hit the pond? Can you make the bear shadow hit the tree? How can you make it longer? How can you make it shorter? Well, we did it live. We did this live during a broadcast after reading the book. And then children went outside, and these are the pictures they sent to us. They tried it outside and investigated their shadows. So there's opportunities to do it virtually, and then they do homework, and then they bring it back the next week. Another project we have is, again, the ASP is all about working with professional scientists to improve their ability to teach. And in this case, improve their ability to engage with the public. This particular project actually focuses on having scientists probe their audiences to constantly check and make sure their audiences are with them, they're understanding them, they're not using jargon. But the other reason to probe an audience is to learn and improve your teaching, and also to have the audience more engaged with the activity. So it doesn't become a one-way discussion the way I'm doing right now, but it becomes a back and forth dialogue between the scientist and the public. Well, we had to go virtual with this project. It was never intended to be virtual. In fact, we made a point in the original proposal to the NSF that we weren't going to look at virtual engagement. This was all going to be live engagement at science cafes and museums and face-to-face type of stuff. Well, we've completely had to retool the project. So here we're doing a training session with some scientists who are learning some of these techniques. And here's a technique that we're teaching them. We have too many people at this meeting, I think, to do an annotation, but if this were a session in which this were possible, let's say I'm doing a talk on, I'm a lunar scientist and I'm about to do a talk on my research on lunar science. I might start with this, and I might say, here is a picture of the Earth, and here are 4 possible pictures of the sizes of the moon. One is almost the size of the Earth, one's about a half, one's about a quarter, one's about an eighth. Which do you think is the closest to being correct for the size of the Earth and moon? And you would use the annotation feature in Zoom to click on what you think is the right answer. Why do that? First, your audience then becomes kind of curious. Well, did I get the right answer? You get a better sense of what your audience knows. And you can open up a dialogue. You can literally, if you wanted to, divide the group into 4 larger groups, into 4 breakout sessions, and have them discuss why they picked that answer and come back and explain it. There are lots of things you can do that are interactive in a Zoom session. We're also linking these scientists up with children who are isolated at home right now. So these children are at the YMCA, and these YMCA children are the children of essential workers. These are children who are being supported by the YMCA. And some of our scientists have been doing some work with them. And here's an example. The kids were asked in a session about the Earth and moon, the Earth takes about a year to orbit the sun. What about the moon? Does it orbit the Earth? The moon orbits once a day, the moon orbits once a week, the moon orbits once a month, the moon orbits about once a year, the moon does not orbit the Earth at all. So you get a sense of what the kids think. They get to articulate their ideas. These kids were all in the age range of about 7 to 9. Gives you an idea of what they were thinking. Another one is about meaning making. Some of you might recognize this as a tardigrade. But to these kids, this is an alien in space, right? Basically, it was a very open-ended question. This is an animal that lives on Earth. What does it remind you of? What do you notice about it? And again, we want to teach children to not just look, not just observe, but what do they notice? And they noticed things like it looks like it has legs, it looks like it has these claws, it has a hole, maybe it's a mouth, maybe it's a nose, I don't see its eyes, how they just started to really take a look at this critter, and they noticed it must be very small because these seems like leaves. This looks like it isn't a very big animal. It's not the size of a tiger. Again, scientific thinking, pattern recognition. Well, for those of you who are interested, we're going to be talking at greater depth about science literacy, and particularly embracing the future. And we're going to talk about what science literacy means now. We're going to be talking about diversity and inclusion and how the Black Lives Matter movement should impact how all of us think about teaching so that it's less racist, unintentionally racist. And also we'll be looking at climate change as well, because least we forget, we still are in the middle of that crisis too. And this will be our 132nd annual meeting, and the first time it will be virtual. So those of you interested, you are the first to hear about this, by the way. We have not yet advertised this, but it will be advertised relatively soon, and we're looking at the dates of December 3rd to 5th. Those of you who are already not members of the Astronomical Society of the Pacific, we are international, and membership is not terribly expensive, and you get to support the work we do, because members are a very important part of what we do and supporting it. But also you get to come to our meetings at a discount. You get our Mercury magazine, you get our astronomy beat, you get our newsletter, you get a lot of wonderful things and discounts in the store. And if you want to know more about scientific literacy, I found this very, very good, thorough, complete review article on the history of science literacy and what it is and why does it matter. It's written by Carol Anelli. It's actually in the American Entomologist, and you can just find it online, actually. If you just type in scientific literacy, what is it? Are we teaching it? And does it matter? Or you type in her name. It's a PDF. It's free. You can just read it. And, my final thoughts on this is this time, even though, we look at the world around us and we just think it is about as anti-science as it's ever been, it's actually not true. There have been anti-science movements in the past. What's different this time is the danger of it becoming institutionalized. And the more that we can work together to stop the global pandemic of science illiteracy, I think the better off society will be. And that might be an obvious question, or an obvious thing to say, but I would really love to hear what others of you think about how astronomy could be used to promote science literacy. So I'm gonna stop sharing my screen. There you go, 40 minutes, bing.
A round of applause for Linda.
Yeah.
Shy audience here, Linda. Sorry, we didn't get more applause.
No, I don't need applause.
It there it is, Katana, gives virtual meetings a little bit more zap. Gets to try harder. They know they're going to get that applause at the end.
Yeah, and I, some of this I have to say is just, I've been sheltered here at home since the beginning of March. And I think, it gives you a lot of time to think about the world and what's going on and what we can do about it. Because I think we can. And I think all of us are, actually. All of us are.
Great. Okay, I have a few new questions here. Some are left over.
I'll take the leftover.
Paulo Lim from Brazil, I think. a member from HOU, says, thank you for the inspiring talk, Linda. Will the ASP 2020 be free of charge?
Oh, no. Well, we will, no. we are not as well off as the global hands-on universe.
Right, we're very wealthy. We had a eccentric billionaire give us a lot of money. Joke.
We do charge a little bit. It'll be a 3-day conference. We charge a little bit only because it takes a lot of our staff time to put it together, and it's part of what we do. It won't be shocking, and it'll be a lot less expensive than flying. We'll probably live stream some of the plenaries, though. We are looking into live streaming part of it, so that part of it will be free.
Great. Yeah, I know. I totally understand. Sympathize. Let's see. Then Vishal Prajapati says, as I heard, Moon is going away from Earth every year. Distance may be in centimeters. What do you think as Moon is tidal locked with Earth? It may be effective.
Why is it tidally locked?
As Moon is tidal locked with Earth, will there be an effect? I think I'm kind of reading that.
Will there be an effect? Oh, eventually. So eventually, so it is tidally locked, yes. But another thing that's happening is the Moon is moving farther and farther away from the Earth. And just like an ice skater putting her arms out, right? You slow down when you do that, and eventually it'll all reach kind of an equilibrium state, or a lowest energy state, or angular momentum state, where the Moon will no longer, where everything will be tidally locked. In other words, the Earth and Moon, the Moon will rotate or revolve around the Earth the same time it takes the Earth to rotate. So wow. Those two periods will be the same. So some lucky winner on Earth will always have the Moon in their sky. Somebody will get that. And then, you'll have to travel the globe to see the Moon.
I heard HOU friend.
In my understanding, the Moon go away. It's not due to the Moon is tidal locked. Actually, the Earth is not tidally locked. That's the reason why the Moon is accelerated.
Yes, that's right. That's exactly right.
There's kind of a tragedy coming up. HOU friend Jay Pasikoff gave a talk a week or so ago, I saw, at the Orange County Astronomers. And I think in 480,000 years, we won't have total solar eclipses because of this.
That's the other problem. As the Moon gets further and further away from the Earth in its orbit, right? We happen to be in a very lucky spot, right? Where the Moon and Sun have the same angular diameter in the sky, right? But as the Moon drifts further and further away, its angular diameter gets smaller. That's it for solar eclipses.
For those folks wanting to cryo freeze themselves and wake up in 500,000 years, they might be disappointed.
They will be, yeah. Somebody, I think I see in one of the questions is the status of Project Astro.
Yes.
Thank you for asking. I forgot to mention that. We're resurrecting it finally. So let me explain this. Project Astro for years and years was unfunded. I mean, that makes it difficult to resurrect. But one thing we've been wanting to do for a very long time is make it entirely virtual. And the reason for that is we would like to focus on bringing astronomers of color and astronomers who represent the underrepresented groups to classrooms. But it's very difficult to do live because statistically, there are not as many. And it's onerous to travel to classrooms. But if we can do this virtually and have, I froze, but I think I'm still talking. Oh, here I go. If we can do this virtually, we can substantially enlarge Project Astro and bring many, many more astronomers to classrooms that normally wouldn't get a scientist. I would love it all to be face-to-face, but it's an experiment we're going to try. So we are putting a proposal together to the National Science Foundation, and fingers crossed we'll get that funded. And so that's our plan.
Great.
Yeah.
Carl, can I make a comment on Linda's talk?
Of course.
Okay. In Japan, of course, we have the very severe situation both in COVID-19 and also the less of the science literacy, especially for politicians. So the one of the governor of the Japanese prefecture make a public release. So the some medicine is very effective to the COVID-19, but his evidence is only just 40 samples.
Yeah.
So fortunately, many Japanese people think that is very strange. It should be not correct. So the people can has a hint. What is actual scientific research? So unfortunately in Japan, I think that is due to the educational system, national educational system. Many people believe the science is a fixed one, and present absolutely correct answer as soon as possible. No, immediately.
Yeah.
So that is a very lack of what the actual scientific research way. So these HOU and some other many educational staff is very helpful to understand the science is not fixed. In some cases, scientists make wrong. So you are in your talk, you showed the Halleys Comet and the presentation by Flammarion.
Yes.
So that is a good example, and we should, and we mean all people should know that such a misunderstanding is not currently, but also not only the old days, not only currently.
Yeah.
We always make such kind of mistake. So that is a very important, and we can appeal what is the actual scientific method.
Yeah, it really centers around that, doesn't it? I mean, if you know that what happens if you don't understand the process of science, when somebody like in the US, like Anthony Fauci, who is an expert in epidemiology, says in the beginning of the pandemic, masks are not a good idea, you don't need them, and then changes his mind. The public thinks scientists don't know anything. They keep changing their mind. They don't understand that we're not just arbitrarily changing our mind. It's evidence that piles up to a point where we have to say that our previous beliefs have to change. But to the public, scientists keep changing their mind, but this person here who tells me, you know, I should be doing this thing, he never changes his mind. So this guy, right, is probably who I should believe. And if we start really young with, go ahead.
I believe the best example is the relativity. Many people believe the people change mind because of the Einstein proposed that, but actually it is upside down. Einstein is not great before release the relativity. After the present is the idea of the relativity, then we think he is genius.
Yeah, that's true. What I'm curious about from other folks, and maybe they can write it in the chat or in the Q&A, in your countries where you're listening to this from, are are you finding the same kinds of theories about flat Earth, theories about anti-vaccination, theories about, or is that just in the US, or do you have different odd ideas? Just curious. Let me see what it, if anybody, would they say it in the Q&A or the chat? We have Jambu Dweep community. What is Jambu Dweep? This is in India. They're believers of flat Earth also in India. Okay, okay. Anybody? Anybody? In Brazil, there are both nonsense about the same percentages in the US. Yeah. Yeah, it's not a, you know, I take some comfort in the fact that it's not just Americans. It is a global, it's a global thing. And I'll just add this. Yeah, is the name of the Earth. Got it, got it, got it. You know, in a global community where we're have access to so much information on the internet with no ability to filter, right? With no, if we don't educate the public into really drilling into what they read, like if you read that, you know, some scientific conclusion, who said it? What's their expertise? What's their evidence? How do they know what they know? How was that claim derived? And you have to drill into it constantly. If you don't teach people to do that, then anything you read has equal weight. And I think, you know, as that's something to think about when we try to promote science literacy as astronomers. How can we teach people to be better consumers of information and be able to really analyze statements? And it does start young, which is why we're doing a lot of work with preschool kids. You know, you have to start the skill early and build and build and build and build. But Brazil isn't America.
Okay, in Japan, I think the shortest, one of the shortest way to transfer such kind of the understanding way. So it's not only direct to the public, but also through the mass media. So at first, educate mass media persons at first. So the Junichi Watanabe,
that's a good point too.
and they he have a lecture for the journalist.
Yeah, journalists like to be sensational, and it was interesting to me that when Halley's Comet came, they didn't take the entirety of Flammarion's comet. They only took the part that said, "Yeah, we could die," and not the chances are pretty unlikely. And I think everybody's going to love this comet. I mean, that part was not as interesting, right?
So Watanabe-san thinking about to educate the journalist to give basic astronomy lecture regularly, and fortunately, not few, at least several journalists join regularly that lecture. I heard. Do you have any comment of that Kisha lecture in Yamaoka-san?
Yes. Indeed, that effort continuously done by Public Relations Office in NAOJ, which I am promoting. And many scientific journalists joined that meeting, but it is also important to comment to any astronomical events, or for example, the fireball observed above Tokyo was very highly news in the news. But and there has been many misunderstanding that the fireball is meteorite. Not meteorite is the storm after its landing. We should we very emphasize that the fireball is not the meteorite. So then last night or the day before yesterday, another fireball appears in the Tokyo area, and they said in the news it was fireball. It is a good teaching for the mass media, I think.
Yeah. Well, we have a society in the US, the AAAS, the
Yes, I have joined it.
It's getting late for me, Carl. The American Association for the Advancement of Science. There we go. And they do an enormous amount of work educating journalists, but the journalists that go to the meeting are science journalists, science writers. You know,
Yes.
It's the ones that aren't science writers that I would like to have them go to the meetings. And anyway.
About 4 minutes, Linda.
I have 4 minutes. I have nothing else to say. I think people probably want to go on a break.
Should we give people a 3-minute break, Toshihiro?
Yes.
Okay, 3-minute break, hey?
Thank you very much, everyone.
Yeah,
Stay
round of
safe.
applause for Linda. Thank you.
Linda.